Hi. Okay, so we are going to work on the last section of this chapter, section 1.10, and this is dealing with what we call a mole. The mole is probably the most universal word that we use in general chemistry. We're going to be using it from this point out. And what is it? A mole is a quantity. Just like a dozen is 12, a trio is two, a gross is 144. A mole has a number associated with it. So it doesn't matter what we're talking about. It could be a mole of anything. It has a number associated with it. And that number is a relatively large number. It is 6.02 times 10 to the 23rd. So if I have 1 mole of apples, then I have 6.02 times 10 to the 23rd apples. So we're actually going to shorten this. So you can take off that, and we're going to leave it at 6.02 times 10 to the 23rd. This number, or this quantity, or this ratio is called Avogadro's number. So that'll be important as we go on. Now, we can use the mole to convert between things, just like we can with, let's say, a dozen. If I have a dozen apples, I have 12 apples. So I can convert between a dozen and then how many apples I have. So for a mole, we're going to start here. We're just going to look at this and using Avogadro's number. So if we have 1 mole of carbon, let's go ahead and take out that word right there. If we have 1 mole of carbon, then we have 6.02 times 10 to the 23rd carbon atoms. If it's just elemental carbon by itself, we're simply talking about its atoms. If I have 1 mole of oxygen, then I have 6.02 times 10 to the 23rd oxygen atoms. Okay. So using Avogadro's number, it will allow us to give a quantity to a mole of whatever type of element or atom that we have. All right. So, like I said, we're going to use this as a conversion factor. And as we know, we're going to take our conversion factors and set them up as a ratio. So here's an example down here using Avogadro's number. 1 mole over 6.02 times 10 to the 23rd atoms. So if I have 1 mole of carbon, it would be 6.02 times 10 to the 23rd carbon atoms. Or I could flip it. Either way, it means the same thing. Which one we use will depend on which one we're solving for. If we're looking to convert to moles, then we'll use this one where moles is on top. If we're looking to convert to atoms, then we'll use this one where atoms is on top. Let's look at an example. So here I have calculate the number of carbon atoms in 2.45 moles of carbon. Okay, so here I have 2.45 moles of copper. And I want to know how many copper atoms that is. Okay, bear with me for 1 second. Hmm. Sorry. Okay, so here I know I want to go from moles to atoms. So I need Avogadro's number. I know that 1 mole of copper is equal to 6.02 times 10 to the 23rd copper atoms. Okay, so that's going to be my ratio. That's what I'm going to use in order to convert my 2.54 moles into atoms. So I have 2.45 moles of copper, and I'm going to use that ratio to cancel out my moles and solve for atoms. So the 1 mole will go on the bottom, and the 6.02 times 10 to the 23rd atoms will go on top. So when I do the math, my moles cancel, and I'm going to take 2.45, so 2.45 times 6.02 to the 23rd, and that's going to give me an answer of 1.47 times 10 to the 24th copper atoms. Okay, and I'll do 1.47. I have three significant figures there. I have three in my initial problem. So that'll be my answer. 2.45 moles of copper contains 1.47 times 10 to the 24th copper atoms. Okay. Let's look at another one. Let's look at it using the reverse. Here I'm given that I have a pure silver ring and it contains 2.80 times 10 to the 22nd silver atoms. How many moles of silver does it contain? So here I want to go from atoms to moles. Again, we're going to use Avogadro's number. So I know that 1 mole of silver is Ag, is equal to 6.02 times 10 to the 23rd silver atoms. Okay. So that's going to be my conversion factor. I always start with what I'm given. So I have 2.8 times 10 to the 22nd silver atoms. Okay. And I'm going to multiply that by my conversion factor, Avogadro's number. I want to solve for moles, so moles is going to go on top. So I have 1 mole of silver, and then 6.02 times 10 to the 23rd silver atoms on the bottom. Okay. So my atoms cancel. So this math will be 2.80 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. And that will give me 0.0465 moles of silver. And that will be my answer. Okay, moving on, one other type of conversion that we can use with moles. So we know that Avogadro's number allows us to convert from moles to a quantity. So how many atoms we have, how many different type of particles we have. But it doesn't tell us anything about mass. It just tells us an amount. So we have another conversion factor, and it's called the molar mass. Okay, and the molar mass is based on 1 mole. This is where you're going to use your periodic table and you're going to look at the mass that's given to us for each individual element. So, for example, if I was talking about carbon, 1 mole of carbon, we know that 1 mole of carbon contains 6.02 times 10 to the 23rd carbon atoms, but we don't know how much it weighs. So, we're going to look at carbon, and when you look, go ahead and look at the periodic table. Find carbon. Carbon is atomic number 6. So you see here, we have our atomic number on top. And then if you look, we have a mass number on the bottom. And for carbon, it says 12.01. Okay, that mass number is going to be equal to the mass of 1 mole of carbon. We're going to see different units for this. We're going to see something called AMUs. That's atomic mass units, but you know what? We're going to make it even simpler. We're just going to say that it's grams. 1 mole of carbon is 12.01 grams. When you take that number from the periodic table, you want to go at least 2 places past the decimal if you're given more decimal places. So this tells us how much it weighs rather than a quantity. All right, so let's go here. Let's stick with carbon. So we know that if I have a mole of carbon, it weighs 12.01 12.01 grams. And we also know that there are 6.02 times 10 to the 23rd carbon atoms that has that mass and is equal to a mole. So this gives us a way to convert between grams, moles, and atoms. Hence, moles though is our central unit. Okay, so just like Avogadro's number, we can set up as a ratio. We can also do the same with molar mass. So we could have 1 mole of carbon is 12.01 grams, or there's 12.01 grams of carbon for every 1 mole of carbon. Okay. Conceptually, this is what you're looking at. If so, we're only here with the element. We'll talk about the molecule in a later chapter. But if we're going from grams of, let's say, carbon to moles, we're going to use the molar mass to do that conversion. So there to there, or vice versa, that's going to take our molar mass. And then if I'm going from moles to the quantity, the number of atoms, this is where I'm going to do Avogadro's number. Okay, so let's look at an example. How many copper atoms are in a copper penny that has a mass of 3.1 grams? So I'm given a copper penny that weighs 3.1 grams, and I want to know how many atoms that is. So I can't go directly from grams to atoms, right? I first have to go to moles. So my conceptual layout here is I'm going to go from grams of copper to moles of copper to atoms of copper. And what I'm going to use to go from grams to moles of copper is the molar mass. And then from moles to atoms of copper, I'm going to use Avogadro's number. And I'm just going to write AV right there for that. So I think the first thing we should do is figure out what's the molar mass of copper. So 1 mole of copper is equal to, so take your periodic table. Copper is atomic number 29, and it has a mass of 63.55 grams. Okay. So we need to look that up before we can solve this. All right, well, we'll always start with what you're given. Sorry, that was a little sloppy. I have 3.10 grams of copper. My first step is going to be to go to moles of copper using this molar mass. I want to cancel out the grams, so the 63.55 grams on the bottom and 1 mole of copper on the top. Okay, so now my grams of copper have canceled, and now I'm in moles of copper. And now I can go to atoms of copper using Avogadro's number. I know that 1 mole of copper is 6.02 times 10 to the 23rd copper atoms. Okay, my moles cancel, and now I'm left in atoms. So I will do the math. So my math is multiply across the top, divide by the bottom. So you have 3.10 divided by 63.55 times 6.02 times 10 to the 23rd. So you should get an answer of 2.94 times 10 to the 22nd copper atoms. Okay, that'll be your answer. I started with 3 significant figures here, so I should have 3 significant figures in my answer. Okay, let's do another one. How many carbon atoms are there in 1.3 carat diamond? We're assuming the diamond is pure carbon. All right, so I want to go to, let's see here. I want to go from carats. In this case, I'm going to go from carats to grams, from grams to moles, and from moles to atoms. It gave me the conversion to go from carats to grams. From grams to moles, I'm going to need the molar mass of carbon. I've actually already looked that one up, and it's 1 mole of carbon is 12.01 grams. So we'll use that for this conversion. And then moles to atoms, we'll use Avogadro's number. Okay, so let's start with what I'm given. I have 1.3 carats. Okay, I'm going to go from carats to grams. Carbon. Okay, so my carats cancel. Now I can go from grams to moles using the molar mass. So 12.01 grams, 1 mole. The grams goes on the bottom because I want those to cancel. I want to get to moles. And now I can go to atoms using Avogadro's number. So 1 mole of carbon is 6.02 times 10 to the 23rd carbon atoms. Okay, then we'll do the math, and we get 1.3 times 0.2 divided by 12.01 times 6.02 times 10 to the 23rd. And I have 1.3, oops, sorry, I don't know what happened there. 1.30, or actually just 1.3 times 10 to the 22nd carbon atoms. Okay, I'll skip that one. All right, so it's not always 3 steps. Sometimes it's simpler. Here it says calculate the amount of carbon in moles. So I want to know the moles of carbon contained in a 0.0265 gram pencil, which we're assuming is all carbon. So we're going to go from grams to moles. So going from grams to moles, it's 1 step. This is simply using the molar mass of carbon. And we've just looked that up. 1 mole of carbon is 12.01 grams. So I have 0.0265 grams of carbon. All right. And then I'm going to cancel out my grams. So my grams will go on the bottom here, 1 mole on top. So simple math, we'll do 0.0265 divided by 12.01. And that's going to give us a small number of 0.00221 moles of carbon. And that will be your answer. 3 significant figures, 3 significant figures in the problem. Okay, this is just the same thing using copper. So simple mass to moles. So calculate the amount of moles of copper in 35.8 grams. So this is going to be the same thing, 35.8 grams of copper. I'm going to use the molar mass as my conversion. We've actually already looked up the copper, and we know that 1 mole of copper is 63.55 grams. So I have 35.8 divided by 63.55, and that gives me 0.563 moles of copper. Okay, so again, grams to moles, moles to grams, we're going to use the molar mass. Moles to atoms, atoms to moles, we're going to use Avogadro's number. You can't go directly from grams to atoms or atoms to grams. You have to go to moles first. And so there's our conceptual plan. So we'll get to this part in a following chapter, but for now, we're going to leave that as is. All right.